Yes. Okay. No, sound is okay. Okay, I will present you. So after having seen this prospective scenario which describes the world in which the possible futures, I will present you some modeling exercise more focused on the automotive market. So as we have seen, our scenarios described potential futures, and we have developed, based on these scenarios, different approach of modelization to make a projection of different topics such as overall mobility, evolution of the market of commercial vehicles, and the evolution of the powertrain mix, powertrain market mix in terms of fuels and technologies. And we have a transversal model in terms of fleet modeling, which allows us to forecast fuel demand of the passenger car fleet, and which is useful also to improve consistency between these different modules. And I will describe you these two models, the fleet model and also the forecast of the powertrain, which is a little bit more linked with the topic we see in this seminar. So concerning this powertrain market mix, the question for us is to see what can be the future in terms of technologies. And we have reinforced this activity since 4 years because the market has evolved a lot. The historical situation is that we have mainly two kinds of technology to develop, diesel and gasoline, with derivative with CNG or LPG, but it's not very different from gasoline engine. And since the beginning of the 2000s, the variety has increased a lot, mainly due to hybridization, due also to development of the South American market with biofuels, ethanol, and the electric powertrains with different possibilities, BEVs, battery electric vehicle, range extender, or plug-in electric vehicles. And for us, it's and if you look to the future, there's a question of hydrogen, perhaps not for the next 10 years, but after. And we have to keep in mind that for us, it's developing one of these technologies, something like $500 million of capex and R&D, and linked to this diversification, the past 5 or 6 years have been a big increase of the capex and R&D budget for powertrain in the share of the overall capex. So we have to be very careful in the choice we made.
Excuse me, but
yeah.
you mean that the share of R&D is declining?
No, it's not declining, it's increasing. The powertrain share is increasing.
So when R&D is decreasing, then the R&D share is...
No, it's not a ratio, it's capex plus R&D. It's a, yeah.
Just mention what is capex.
Capital expenditure for investment, yeah. And since the share of the powertrain, which is increasing compared to body shape or equipment or whatever, different parts of the car. And so, second point is that we have to choose our solution in a global manner because it's no more feasible to develop a technical solution for a given market, for example, only for Europe or only for China. And these markets are quite different in terms of car type. For example, you can think about the Chinese market or American market, which is with big cars, big SUVs, 100% gasoline. And we have markets such as India or Europe, which is market with small cars and mix of diesel, gasoline, and sometimes natural gas vehicles. These markets are very different in terms of maturity and dynamic. You see in this picture, it's evolution of the car market in volume. China in 2003, it's something like no market. 10 years after, it's the first market in the world. And on the opposite, you have Europe. It's a big market, a little bit decreasing since the next 5 years. but very mature market. The volume is quite steady. Equipment rate also, that's something that we can see here. Where is the car fleet in 2011? You see that with a market of 15 million, we have a fleet of 240 million cars in Europe. And look to China, it's in 2011, it was 55. So a market which is increasing a lot with a park which is quite very small for the moment, with a huge population. And Europe, which has a stable market with a very big fleet. And in these different countries, the customers are different also in terms of repartition between the different segments in terms of behavior and in terms of purchase capacity. So to cope with this complexity, we have built a model for powertrain markets. On the top, we have a description of the global environment and part of the ecosystem with economical topics, GDP growth, incomes evolutions, oil price, fuel taxation. So all the regulation chapter is very important for the fuel, for the car usage, question of access restriction, development of refueling or recharging network, all these parameters which describe the environment of the automotive. And on the micro side, I would say, we have offer and demand. So on one side, we have the customers. We use a detailed customer segmentation because there's no mean customer. We can, for France, for example, we cannot consider that there's an average customer. We have to look to different kind of customers. We have something like 18 segments of customer, and we start with a measurement, we say, or a survey of the actual customers that we describe in terms of usage type, mileage, buying criteria, and budget, and we make some assumptions in terms of customer repartition in the next 10 or 20 years. And on the other side, we have the same kind of assumption for the technology and product offer. We make some hypotheses on the evolution of the cost of the technology, evolution of the attributes in terms of fuel economy, CO2 emissions, but also the soft attributes such as performance, silence, comfort, things like that. And as we want also to make some forecast in terms of fuel consumption to see how the market will be compared to the regulations, we make also some hypotheses on the evolution of the vehicles in terms of performance for fuel economy with the weight, aerodynamics, and friction losses. As I was saying just before, this is the description of the elementary mesh of the model. We have on one side the customer clusters for the B2C, so business to customer and business to business market. And on the other side, it's vehicle segment, small to big vehicles. So the elementary mesh is the cross between a customer cluster and a vehicle type. For example, M1, it's a 308 type or a Golf type. And we have a different kind of customer in this vehicle segment. And for each kind, we have a description of its usage in terms of kilometers and distribution of these kilometers by usage, of incomes and effort rate. And also we have, we say, soft parameters, buying criteria. Is priorities to have a very low usage cost, or is it purchasing price, vehicle performance? Is this kind of customer are very sensitive to environment, for example, etc., etc. And all these parameters are used in a multi-criteria market repartition model, which is which run for each elementary mesh. And in this model, we mix, in fact, three kinds of factors: economical factors to assess in regard to the price of the technology, the budget and price elasticity of this customer type. We have the usage, because some technology have limitation for usage, such as BEVs, for example, which have limited range. So we need to know what share of the customer can, let's say, for what share of the customer this technology is compatible. And after that, we have a choice criteria ranking. So it's just the motivation or the preference of the customer that we mix with the attributes of the different technology. Here is an example of the results. Sorry, there's not the numbers because it's not shared results. For different scenarios, here it's the, in 2020 somewhere, in some country, the hybridation potential. It's a potential because it's depend, in this picture you don't see one effect, which is the offer effect. If in 2020 there is only 2 OEMs in Europe or in whatever who are offering this technology, for sure the market cannot be 30 or 40% of hybrids because the market will be limited by offer. So in this example you see the different scenarios that Serge has presented you before, the constraint optimization, green taxation, double squeeze. And in these scenarios we have a significant variation of the potential of hybrids and the potential of plugins. In the plugins, which are in pink, it's a battery electric vehicle, range extender, and plug-in hybrid. Yes. And so, in fact, depending on the main factors that explain the evolution, it's technology price in regard to the economical situation. As you have seen for double squeeze or constraint optimization, the economical situation is GDP is quite low, so people has not the money to afford the new technology. And the opposite in the green taxation, GDP is quite is high. There's high environmental ambition, so that means high regulation, and so people can afford the technology. Concerning the development of electrified mobility, you have seen that in the previous simulation with the parameters we have chosen the market share of the electrified mobility, so plug-ins, BEVs, battery electric vehicle, range extender, and plug-in hybrid is quite low. This is due to the hypothesis we have put in the model, and in fact it's linked to different bottlenecks for the development of the electrified mobility. The first one is that this technology has a charging need, so the customer needs a plug to charge his vehicle. And today there's only a partial share of the population who have the access on a public charging network, or who can plug his car at home and office. Second point is the range in terms of usage. If the customer need a polyvalent vehicle because you want to travel through the country, a BEV is not adapted, or you need a lot of time. And also for the usage cost, because for mainstream customers, if they choose BEVs or electrified, it's to save money because electricity is cheaper than fuel. But the problem is that the battery are quite expensive. So he has to see if his usage is enough compatible with the electric autonomy to have a good payback for this investment. He has to have enough money to put in his car to buy it because electrification costs money mainly due to battery price. And at the end, it has to fit with its preference in terms of attributes. This is for the market mix model, and so this evolution of the market in terms of powertrain mix, we are implemented it in a fleet model in order to see what's the impact in terms of fuel demand of this powertrain and technology mix. Also, we try to see what's the market volume and segmentation evolution, because we forecast for the different market, the market in terms of volume, but also what will be the market share of SUVs or small cars in the next 10 or 20 years. And also we use it for feedback to improve consistency between models, for example, mobility models with the result of the overall fleet mobility. It gives us a feedback loop to challenge the mobility forecast, and also the market volume forecast if we cross-check equipment rate forecast and market volume. And we have some comparison also with the external scenarios such as IEA or IHS, who are producing some forecasts in terms of fuel demand for the fleet. So basically, fleet model is quite simple. We start with a reference year and description of the actual fleet in terms of age, fuel mix, and fuel consumption of the different vehicle, and the mileage by the age of the vehicle. And we try to have this same kind of results for the next 20 years, integrating the evolution of the market in terms of volume and structure, and with parameters that we have to set and that are useful to make the consistency feedback. Is the survival law. So at what age does the vehicle are going to scrap? And equipment, in regard, it make evolve the equipment rate and the annual mileage evolution, because regularly we use a law which tells us for a vehicle, for example, 10 years old, makes 30% less kilometer per year than a new car. The more the car is used, the less the people are driving. To come back to the question of the fuel demand, I will talk a little bit about the parameters and drivers of the system to reduce this demand, because sometimes when we talk about the problem of energy in the transport or car market, people say, okay, you just have to produce cars which are very light and very aerodynamics and very efficient. So just to be provocative, I have put an example a little bit extremistic. So the problem of this car is that for most of the customers, they are not so happy with that, even if we think that the average age of the customer in Europe is 55 years. So you have some constraint for accessibility. And the second point is you have to just use clean and abundant energy. So it's a little bit simple to think like that, because as you know, to measure the impact of such a measure, you have to think about the fleet impact. And just to fix the idea, for example, in France, we have one insight, which is what is the mobility demand? What kind of mobility does the people want to do with a car? And to make this mobility, we have a fleet. For example, in France, it's around 30 million. And the average usage, it's 12,000 kilometers per year. And this fleet is composed with different type of vehicle in terms of energy, diesel and gasoline, with a repartition, which is for the passenger car in France, 56 diesel and 44 gasoline. And this system has some inertia, because if you want to put a new technology which is very efficient or something like that, you have to keep in mind that the overall new car market is 2 million. So for example, to simplify, if we switch this 2 million in only one type of car, very efficient, it will take 15 to 20 years to achieve this fuel economy for the overall fleet. So it's quite long. And if this technology is very expensive, it will only take a small share of the market. So that means the time will be very long. So you have to find the right tuning in terms of ambition or technology content increase and diffusion of the technology. And one of our big problems is that in each step of this thing, there's a customer, and it's not so predictive. No, customers, it's a generic. Ladies has short hair also. Sometimes. Faut que je conclue, d'accord. Okay. Bon, j'accélère. Okay, so these customers, they are different in terms of needs, motivation, constraints, and trends. And it's not possible to address all these customers with only one solution. We have to think about diversity of solution, of product, and also on services. Very quickly, I will give you some insights in terms of evolution, which are ongoing, and potential level of car, of its usage and driving style. In terms of car efficiency, perhaps you know we have a significant challenge which is defined with the EU in particular, which you see here is the decrease of the CO2 of the new car market in the year. So in 2015, it's 130 grams, which means 5 liters and something for the average fleet. Here it's less than 4 liters and around 2025, but it's not decided yet, something like 3 liters or a little bit less. And you see that the other area like US or China and now Brazil are going in the same direction. So for that, we are developing more efficient vehicles, lighter with improved aerodynamics and less losses and efficient powertrains. We have the lever, but this efficiency car, it's only new car market. You have a discussion about the fuels, but you see that you have many possibilities to in this field. But if you look, for example, here for biofuels compared to regular fuels, depending on the way you produce it, you have a very good impact in terms of CO2 or quite no impact. So it's depending on the country, depending on the resources, you can have different answer. And on the bottom, it's the CO2 emission of an electric vehicle depending on the electricity CO2 content, depending on the country. So you see France, okay, it's very good, electricity is less than 20 grams. If you look to Germany, 90 grams. If you look to China, 140 grams, which is much more than a fuel car. So BEV to reduce CO2 emission in China, it's an interesting idea. Usage, it's a big lever. It depends on the customer also, but it's, for example, in France, there's a question of the filling rate of the car. It's 1.2 person per car, so it's quite low. You have a very optimized but not so safe configuration here. And you are all the new offers which are going in the market like a service use instead of owning, car sharing, co-ownership, very short rental, which will allow to increase the diffusion of the very fuel-efficient technology and reduce traffic jam. Driving style, it's something that you have to think about because, for example, depending on the measures, but the stake is something like 10 or 30% of impact. So if you drive on the highway with the open windows, it's worse than using AC. For this, we are developing some solution of eco-coaching that will help us to drive efficiently your car. And you will have, in the next 10 years, solution with driving automation that will allow you to reduce of 20% your fuel economy on highways. 2 minutes. That's my last slide. Here, it's the fleet of Europe, the evolution of the demand, depending on the scenario. Interesting thing is that we have, for example, here, the reference scenario or the ITER scenario, which is at the same level than the green one. It was a surprise for us, and in fact, it's due to the fact that we have a rebound effect in terms of mobility. Cars are more efficient, but people drive more. So at the end, it's the same results. And on the other scenarios, the best is this scenario, which makes a very quite ambitious in terms of environment with not good GDP. So people drive less with quite efficient cars. And to conclude on this, comparison of the different scenario for China, you see it's not the same dynamic. In Europe, it was a little bit decreasing. In China, not really. And you see it's kind of the jungle of Mr. Criqui for the scenario, but here is for the fuel demand. It's not the PSA scenario. There's a mix of PSA scenario and external scenarios such as IEA and IHS. So to conclude, one of our questions is to have a science for customer behavior. That's it.